So we can see there are two blocks, and the static friction between the two blocks here is 0.38. This surface is frictionless, which is beneath the larger block, and the masses of both the blocks are given. So we need to find what's the horizontal force required, so to keep this mass from falling down, the slipping down basically. So the horizontal force that's applied here will cause an acceleration of both the masses, and there is no friction force here. This is frictionless surface. So if F is the force and if A is the acceleration from second law of motion, we get this one. So we can write A equals to F over m plus lowercase m. Sorry, I don't know what's that, lowercase m. So the force, the horizontal force that's applied, a portion of that will act as the normal force that will cause the frictional force, basically. That will be the frictional force. So if we say that force is F1, then mu F1 for the mass to be not slipping down on this down the larger mass will be mu F1 will be equals to mg. So this is the weight of the downwards weight force of this mass, and this normal force has to be large enough so that it just balances the weight force of this one so that it doesn't fall down basically. So that's there. So we can say F1 is equal to mg over mu. So now we want to figure out what is F1. So if we think of these two these two blocks are not attached, but they are moving together. So because the force is applied here, there is a reaction force from the second block to the first block here, and that reaction force will be the normal force that will be causing the frictional force so that it doesn't fall off. So normal force here. So if we want to find out, if we call that is the force, so that is actually F1, that's reaction force is the normal force. So if we want to find out what is the force that is causing the acceleration of only this block, of only lowercase m, the smaller block, that would be F minus F1, of course, because this is the total force and this is the reaction force. That is actually the force that is causing the acceleration here. So F1 will be ma, uppercase ma. So if we want to write lowercase f ma, that will be F minus F1, that will be lowercase ma. This is uppercase ma, so if it goes on the other side it becomes the full F, of course. So F1 we know this one, so we can write this is equal to ma plus mg over mu. So this is actually this one here. So instead of a, now we will write that's m here, and that will be F over m plus uppercase m plus mg over mu. So if we take this on the other side, we get something like this: F here, m plus m, and this is mg over mu. So if we take F here, it becomes 1 minus m over m plus m, and then this is mg over mu. So if we just take that as a division, if you write that as a division, it becomes like that. So times here m times sorry, that's not, there is no m here. So basically 1 minus m plus m, and if we plug in the values now, so this is a product here, as too much space there, so we get something like almost 488. So basically this one is 16 times 9.8 16 is the lowercase m, then mu is 0.38, and here I have 16, the lower mass of the lower the smaller block, and this is 16 plus 88. 88 is the mass of the larger block. So if when we do it, when we do the calculation, we get almost 488 newtons. So that is the minimum horizontal force that needs to be applied so that this mass doesn't fall off. The normal frictional force here is enough to withstand the weight force which is downwards here.